Hi, I'm Rainer, and this week we're going to be doing a torque problem. So, in this problem we've got basically a stick of length L, and it's leaning across the ground, or it's leaning on the ground, and it's got a block hanging from it with mass MB, and it's also got a person who has a rope tied to it here, pulling with some force F. And our goal is basically to find the F such that this thing stays still. So, what we're going to do is this. We see it clearly looks like torques will come in handy in this problem. So we've got to do a couple of things first. I've drawn an extended free body diagram, just showing all of the different forces and where they're acting, and I know all of these angles and such. But one thing I need to do is choose a good axis of rotation. And it seems like a pretty natural place is the place where it actually rotates about, which is right here. So I'm just going to throw that on here, and then go ahead and say that's my axis. The next thing I'm going to do is just choose a clockwise or counterclockwise direction to be positive. And just for fun, I'll choose this way to be positive. And that's completely arbitrary. Now, at this point, we can say, alright, we want to find this F. And we know these forces, we know their distances, and we know that this thing doesn't rotate. Right? So if we want to, we can just go ahead and sum our torques, and we can see that that's a really nice decision, especially with our axis choice, because this normal force doesn't have a torque with this axis because its displacement is 0 from the axis. So let's go ahead and do that. Let's sum the torques. If we sum the torques, then let's take care of this one first. We remember a couple of general ways to think about torques. We can either think of it as RF sine, I'm going to call it beta, where beta is the angle between them. And that's also R perpendicular F or F perpendicular R. And these are all for magnitudes. If we wanted to find the vector, we would take a cross product. So, in this case, we've got this way positive. So let's take care of this guy that we want first. We know the distance away, I should have told you this, it's a distance d away from this axis. So that's going to go in for our r, and since we have this angle already, I really like the sign of the angle between them. That formula looks good. So I'm going to say d for my r, f, I'm just going to call it Fys, force of u on the stick, and then sine of whichever angle's between them. And I see r looks like this, f looks like this, so theta definitely looks like it's in between them. And it's going in the positive direction, so I'm going to make it positive. Next, I see we've got two weight forces that we have to worry about. And I know that this angle is phi, and since this angle is phi, this angle is also phi. So, with that in mind, we can go ahead and say, alright, both of these are pulling in the negative direction, but let's just take care of, say, this one first. So, I know it's going to be a minus, we just said it's going in the negative torque direction. I know the distance away, the weight acts at the center of mass of this stick, so I'm going to say L over 2. Then, the force, I know that the weight is just always mg, so I'm going to say mass of the stick times g. And then sine of the angle between them, which in this case is phi. And then last but not least, we have to do this one, the weight of the earth on the block. And notice, I called it the weight of the earth on block, and I made my system the stick and the block, so I can say that. I can say that the weight of the earth on block is acting here because the block is in my system. So, in this case, I think we're going to do this exactly the same way we did the previous two. We're going to say the distance away is L, the full length of the stick. The magnitude of the force is mbg, and then we pick out the same sine of phi term. And finally we say, alright, sum of torques is equal to I times alpha. And I know if this thing's not moving, then alpha better be 0. I'm going to set this whole thing equal to 0. So at this point, we can just solve for F, that's our only unknown, and that's how we can find the force necessary to hold this thing in place. So that's all, thanks.